Okay. So hi, our topic is coronavirus tweets and LP text classification, and our team member is Teng Gao, Huimin Li, Shize Li, and Yiqin Wei. So our motivation is because the COVID-19 pandemic actually affects everybody's life in 2020, and it changes us daily life a lot, and it affects a lot of people's health and the businesses, and also it's basically pretty much everything around the world. So from this data set, we want to know people's attitude towards the COVID-19 pandemic right now, and we want to find out how people actually react to COVID-19 quarantines when they are home, and what they actually did, what actually changed in their life. And we wanted to collect some information about the COVID topics, like the politics changed in the US, and some other stuff like the grocery, food, etc. So we're gonna do statistical analysis and data visualization on tweets, basically focus on the sentiment to see people's attitude towards the pandemic. And we're gonna build a sentiment analysis model to classify the tweets people posted using deep learning methods. And we if it's possible, we can also set up a potential alarm system to see if a certain area actually showing negative or extremely negative sentiments towards the COVID-19. So our data set is coming from Kaggle, and it contains around 45,000 records. It's recorded from March 16th, 2020 to April 14th, 2020. And it contains a variable including usernames, screen names, location, and tweet at, and original tweet contents, and the sentiment, which is our label. So after a basic exploration in our data set, we found that except the location, all other variables does not have any missing data here. But the location column, we do have 9,424 missing data in there. And also in the location column, it does not have a consistent format. We have a sample on the right side. So we decide to get rid of the location column and focus on the original tweet and the sentiment column only. So here's a sentiment distribution. So as we can see, most of the people shows their attitude around the neutral, positive, negative, only a few showing very extreme attitude to this COVID-19 situation. And here is the trend. And as we can see, like the peak showing up around by the end of March, and a little bit at the beginning of April.
Okay, then we will talk about the data processing part. The first step is data cleaning. So we are focusing on the original tweet. So we do some NLP processing for the data. We remove the URLs, remove non-characters, remove stop words, remove some hashtags and mentions, which is especially for the tweets. And then we do the stemming and find the maximum length of the tweets, which is 307 words. In order to perform models on the data, we also need to do data transformation. The strategy we use is first text tokenizer, convert each text into a sequence of integers. We set the maximum words for tokenizer is 20,000, and the maximum length of the tokenized is 300. After tokenizing, we also do padding for the words. to making sure that every tokenizer is the same length. So the padding of our reviews is we pad our reviews to a specific length to make it consistent. For some of the models, we also do factorization, which is very typical for the non-neural network models. The models we are using are in two categories. The first one is the traditional machine learning methods as our baseline. We use logistic regression, naive Bayes, and random forest. And then we also use some deep learning models, which are CNN, RNN, LSTM, bidirectional LSTM. We also use pre-trained glove word embedding. We also use global max pooling and bidirectional LSTM to increase the model performance. The models, the training set and testing set, the training set have 41,000 records, which is from the March 2020 to April 2020. The testing size has 370 records from also March 2020 to, oh no, not March. Okay, March 2nd to March the 16th, 2020. The first model we are going to talk about is the logistic regression, which is our baseline. We can see the results, the confusion matrix have 5 different results, and the total accuracy is 0.61, which is not that bad. And then we also do the random forest. The random forest has an accuracy of 46%, which seems to perform worse than our baseline, which is a logistic regression. We also perform a naive Bayes. Naive Bayes model is a classic approach that people used for text classification before the invention of neural network. So the accuracy is 68%, which is a little bit better than the logistic regression model. And
then we use the recurrent neural networks to build a sentiment analysis model. First, with a simple RNN, and this picture shows its architecture. We can see that it consists one embedding layer, one simple RNN layer, and one output layer. Next, please. This is the result of a simple table on the left lists model parameters and accuracy. We use the 10 and 30 epoch 3428 batch size to train our model, and the highest accuracy is only 0.57, which is lower than our baseline. So the performance of this simple RNN is not good. Next, please. Then we use LSTM model. Picture on the left is its architecture, which consists embedding layer, one dropout layer, one LSTM layer, and one output layer. We train LSTM model with the same parameters as previous model, but add dropout, and the dropout rate is 0.2. The LSTM model performed well with an accuracy of 0.77. Next, here we displayed the model accuracy and loss. We can see that overfitting occurs after the third epoch, where the training accuracy is 81% and the test accuracy is 7%. Next. Next is the bidirectional LSTM. It has similar architecture as previous LSTM model, but it is bidirectional. From the table on the right, we can see the accuracy increased a little bit, and the highest accuracy is 0.78. This is next. Here, this is a model accuracy and loss. We can find that it overfit after the third epoch, where the training accuracy is 80% and the test accuracy is 90%. 79%. In the next part, we use the pre-trained GLOVE word embedding in our RNN models. An unsupervised learning algorithm developed by Stanford for generating word embedding. It was trained on a dataset of 1 billion tokens with a vocabulary of 400,000 words. And in this project, we choose the 100-dimensional word vectors. So in the following models, we will use the same network architecture as before, but use the pre-trained GLOVE word embedding as initial input. This table shows the parameters and results of RNNs with GLOVE. And we can see that among these models, the highest accuracy is 65%, which is lower than model without GLOVE. Next, please. And we think this is because GLOVE ignores the sentiment information of the given text. However, this model with GLOVE converge faster than other models. So this is a trade-off between speed and accuracy.
Okay, to solve the overfitting, we apply some we apply some regularization method, like we add a global max pooling layer after the bidirectional layer in order to extract the important features. And also we add some dropout rate inside the bidirectional layers with around 20% dropout rate. And finally, we achieved around accuracy around 85%, and also for the training, accuracy is around 86%. Next page. Yeah, after we can see from this chart about the training process, our test accuracy curve finally converge after the second epoch, which means it start to overfit after the second epoch. And also, so we can try to stop early after the second epoch, because for each epoch, it will take around 30 minutes for training, which contains lots of computation resources. Next page. After we also try some convolution neural network layers to set up as the model, and also here is our architecture, and we totally have 4 different hidden layers with different number of the filters, and also after each hidden layer, we have different dropout rate layers, and also for after each dropout rate, we have a global max pooling on the last hidden layers. And finally, our accuracy score is around 57% on the test data set, which is higher, which is much lower than we thought. And here's our chart for our training process. Although we initially have an accuracy around 60%, but our test accuracy continuously decreased after during the increase of the epochs. So after around 30 epochs, our validation accuracy remains around 58%. Next. So we dropped some conclusions here, and in our project, we conducted sentiment analysis on the tweets using both machine learning and deep learning approaches. And we set up a logistic regression as the baseline and achieve around 61%. And also we use some comparison models like the naive Bayes LSTM and bidirectional LSTM, and which shows a good performances higher than the baseline. And among all of our machine learning and deep learning models, the bidirectional LSTM using the global max pooling shows the best performances. It achieves an accuracy around 85%. So the bidirectional LSTM with the max pooling layer is going to be our recommended models for the tweet sentiment analysis. And for our future exploration, we will continue to explore in some more other kinds of deep learning models like the BERT in order to reduce our computation expenses, also improve our test accuracy. So yeah, that's all of our presentation. Thanks for listening.
Thank you.